Bismillahirrahmanirrahim. Normality testing and transformation. This is the title of this presentation. In statistics, most of the inferential procedures need an assumption of normality. If a quantitative data fulfill the assumption of normality, then we can apply our testing procedures. Otherwise, if the normality assumption is not fulfilled by the quantitative data, then it is difficult to apply inferential procedure on that variable. The testing normality, whether the given data follows a specifically normal distribution, is one of the very important tasks in exploratory data analysis. Different methods are involved in testing normality. We can test the normality either graphically or by applying some test of normality. What graphs are needed? We can test the normality by histogram, bar graph. Bar graph is not included. Box plot and normal probability plot. So we have to exclude the bar plot because bar plot, the bar graph is not in the list. So I have to eliminate this. Histogram, box plot, normal probability plot, stem and leaf graph. These are the visualizations that can be used for analyzing normality of the data by test. Two different tests are involved. One of them is called Kolmogorov-Smirnov test of normality, and the second test is known as Shapiro test for normality. So in this presentation, we will cover the topic of normality. I am not discussing histogram and box plot in detail in this presentation because this was the part of the previous lecture. But in SPSS, normal probability plot are to be constructed, as well as histogram in SPSS are to be constructed. We may have the box plot in our outputs. How to interpret the box plot in the output, and how to use these graphs for assessing the normality of the data. Then two tests will be explained in SPSS. One of them is Kolmogorov-Smirnov test, and other test is the Shapiro test. If the data after applying the normality test does not fulfill the assumption of normality, we cannot use the parametric procedure of inferential statistics. So before going to apply any inferential procedures on the data, and the data doesn't fulfill the assumption of normality, then there is a procedure involved which is named as transformation. Transformation is what? Transformation is basically defining a new variable by applying some functions. Most probably these functions are the logarithms, square root, reciprocal, and there are many more transformations available. But these three are very common. Our discussion will be about how to transform the data. So in the first step, you have to test the normality of the data. If the data is not normal, then you can apply a transformation on that data. After transformation, if data becomes normal, then we can apply the inferential procedures on the transformed data instead of the actual data. So that is actually the two-stage procedure. Now, what are the transformations and which transformation will be suitable? If we have a data which is slightly right skewed, if the data is slightly right skewed, then square root transformation is helpful. It is suggested that you will use the square root transformation. You have to take just the square root of the actual data and then test the normality of the new data, of the transformed data. Another transformation is known as the log transformation. This log transformation will be suitable if we have a highly skewed distribution. If the distribution is highly skewed, then we can prefer the log transformation. If we have a exponential decay, means very high skewed to the right side, then the formula will be the reciprocal formula. Reciprocal means what? 1 upon x is a new variable. You have to just take a reciprocal of the x is what? X is the actual variable. So you have to take the reciprocal of the actual variable. These three transformations are basically applied whenever we have a positive skewed distribution. If the data is negative skewed distribution, in the same way we have to apply the same three transformation like square root, logarithm or reciprocal, but it is not applied on the actual data. It will be applied on a data which is subtracted from k. What is k? K is the maximum value in the data plus 1. Your max value in the data, whatever you have the maxima in your data, plus 1. Why plus 1? Because if sometimes we have 0 in the data, then logarithm will not be suitable because it will become an error. So instead of taking the k as a largest value, we will use the maximum plus 1 for the value of k. Then you have to subtract k minus x. What is k? X? X is the actual data. What is k? K is the maxima plus 1. So k minus x and then a square root of this. This will be the transformed variable. I can use the name of this variable as y. So y is the transformed variable, x is the actual variable. What is to be do? You have to make a column in which the values of x are to be subtracted from k. K is the maximum of the data, and then take a square root of these subtracted results. This is the formula of transformation which is used whenever we have a slightly negative skewed data. If we have a skewness, negative skewness which is strong, then instead of the square root transformation, there is a suggestion of the logarithmic transformation with the same formula, logarithm of k minus x. And what is k? The same k that I defined in the previous slide. K minus x, x is the actual data, k is the maximum value plus 1 in our data, and this is the new variable, like I'm saying that it is y. Y is the transformed variable. So firstly, we have to check the normality of x. If x is not, and x is a negative skewed distribution, then we have to apply this transformation, and another variable is obtained by this transformation. Then the normality of y is to be checked. If y is normal, if y becomes normal, then we can apply the parametric procedures on y. Otherwise, if y is still not normal, so we have to choose another transformation and check the normality of that transformed data again. So So it is an iterative procedure. You have to apply the normality test on the actual data. If the actual data doesn't fulfill the assumption of normality, you have to transform in a new variable. Then you have to check the normality of the transformed variable. If it is normal, then proceed for the statistically inferential procedures, which are named as parametric procedures. If still the transformed variable does not meet the assumption of normality, then you can use another transformation and so on. If after applying 2 or 3 transformations, we are unable to meet the normality of the data, then there is a last option, which option is a non-parametric procedure. The non-parametric procedure is a qualitative procedure, is not a one procedure, is a family of procedures, which are known as non-parametric procedures. So if data does not meet the assumption of normality and the sample size is small, then non-parametric procedure can be used. But it is the last option for the quantitative data. So for a non-parametric procedure, that these procedures can be applied on any sort of data, is a qualitative data, ordinal data, scale data, we can apply the non-parametric procedures. But preferably, we first have to use parametric procedures, because that procedures are quantitative procedures and they have a high accuracy as compared to non-parametric procedures. Now our discussion will be on practically how to check the normality of data and then take a decision of the procedure which is to be used. And if some transformations are needed, we have to complete the transformation, and then after transforming the variable and data, we will check the normality of the transformed variable too. So we are using one file that is named as survey5vd. This file is already given to you. It's a SPSS data file, and in this data file we have several variables, and we want to check the normality of some of them. In this data file, there is a variable which is named as tpstress. tpstress stands for total perceived stress of the participants. This variable, firstly, I will use this variable tpstress to check the normality by graphs. How can I check the normality of the variable by graph? The procedure is simple. The normality can be checked by histogram, by box plot, by stem and leaf, or by normal probability plot. The new term in this presentation that you are learning is the normal probability plot. Normal probability plot is a graph which is constructed with the two variables. One of them is called x, which is in a range form, which is my actual data. And the second variable is what? Second variable is the normal scores or the z-scores that are given in the normal probability table. So you have to plot two variables. One variable is the actual variable whose normality is to be checked. And the second variable is the z-scores obtained from the table of normal distribution. These two columns are to be plotted on a xy plane. If you are getting a linear line of the points, here is the arranged x and the other is the z-scores. Z-scores or z ordinates. This is taken on the y-axis. If the points are arranged in a straight line, you can call it as data is normally distributed. If the data is in curve, That is the violation of very simple graph it is. So we will discuss this graph into the SPSS directly. Now I am moving to the SPSS and demonstrating this. You are already familiar with this data file. This data file contains 134 variables. These are the two new variables that I have created now. I am just clearing these two variables because I will create these variables here in this presentation. 134 variables we have, and these are some quantitative variables which are under focus of the statisticians. Total optimism, tpstress, this is the variable that I will use for checking the normality, and total negative effect, total positive effect. These are the variables. Now I am going to some variables which are basically the identification variable, the gender of the participant, the age, the marital status, education level, smoking habits. These are the very common variables to identify the participants, and these are some variables which are psychologically we have to check the participants whether stress is how much and how person is thinking, and how the stress is related with the positive effect, how the stress is related with the negative effect, and how the participants are controlling their daily activities is TPOICISS, total perceived control of internal state, how you are organizing your life, how satisfied you are with your life, TSLFEST, life satisfaction, total life satisfaction. This is the variable. Total self-esteem, this is one variable, and total positive effects, this is total life satisfaction. T-life-sat, total life, how person is satisfied with his life. These are the variables. Now I am moving to the data. In this data, we have to analyze the data by descriptive, explore. I already told you the quantitative variables are to be analyzed using explore. So our discussion will be analyze descriptive statistics, explore. In the explore, we have to select the variable. Initially, I want to select a variable which is total perceived stress, tpstress. The tpstress is a variable that I am just choosing here because one of the quantitative variable. This is total perceived stress. And just click the right arrow button in the dependent list to select this variable. In the statistics portion, you have to check the statistics or uncheck the statistics. If you need the statistics, descriptive measures, just check it. Continue. In the plot segment, you have to, one thing which is very important, normality test. As I told you, the two tests are used for checking the normality. One of them is called Kolmogorov-Smirnov test, and other test is called Shapiro test. If I check this box, then these two tests will be implemented by the SPSS. If I uncheck this box, then these two tests will not be included in an analysis and will not be the part of our output. Similarly, if I uncheck the histogram, then histogram will not be the part of our output. So I am checking one thing, that is histogram, and second thing is the normal probability plot with test. Click continue and OK. These are the outputs. You can see the output. I will explain these outputs just using PowerPoint presentation. In the few tables are there, case processing summary, 433 cases, missing numbers are 6. Case processing summary, total cases are 433 and number of missing cases are 6. It means there are the 6 participants whose stress values are not given, which are known as missing numbers. So 439 cases are the valid cases. The mean sample mean is 26.73. This is sample mean, and confidence interval, I already told you 26.18 is the value of the confidence interval. This mean can be represented by X bar, not population mean. And this is basically the lower and upper bound of estimate of population mean. So this is the estimate of population mean, lower value and the upper value. And this is the sample mean. So inferential, this procedure is inferential while this procedure is descriptive. Then 5% trim mean, I already explained the 5% trim mean. The extreme numbers are excluded, and after that, skewness and kurtosis. I am going to explain this. For a normally distributed data, it should be 0 in SPSS. It should also be 0 in SPSS. If these two are exact 0, we can say the data is perfectly normal. If it is 0, 0, then data is perfectly normal. But in my case, it is 0.245, means we have a right skewed distribution. How large number we have here? Thus, as high skewness we have here with the positive side. If we have a negative number here, we have a negative skewness. If it is a very big negative number, we can say that extremely negatively skewed distribution. If it is 0, we call it as a mesokurtic. Mesokurtic means we have a moderate height. Neither too high, which is the characteristic of a normal distribution. Normal distribution, neither too high nor too low. If we have a very big number here, the distribution will be lepto. This is leptokurtic. Leptokurtic distribution. This is called lepto. And the first one is called meso. Lepto, meso. And the third distribution is flatty. So flatty means flat distribution. If we have a negative number here, it is flat. If we have a 0 here, is meso. If we have a very high positive number here, we call it as a leptokurtic distribution. In a leptokurtic distribution, the variance is very low. In a mesokurtic distribution, we have a moderate value of variance, or in a platykurtic distribution, we have a very high variance. Variance is very high, variance is very low, moderate variance we have. So these are some content that are to be very important in. This is the test of normality. Test of normality is what? Test of normality, two tests are here. One output is indicating the Kolmogorov-Smirnov test, and other output is represented by Shapiro-Wilk test. These are the two tests. These are known as tests for normality. By graph, we are visualizing the normality. By test, we are exactly testing whether the data is normal or not normal. In this case, our null hypothesis will be H naught. Stress is, column of stress is normally distributed. Data is normally distributed, and data is what? Stress, or TP stress. Stress data is normally distributed. Stress data is normal. This is null hypothesis. And alternate hypothesis is what? Stress data is normal. And alternate hypothesis is H1 data is not normal. The null hypothesis and alternate hypothesis not normal. These are the two important hypotheses, not normal. Now I am not explaining these outputs here. I will move to the PPT and will explain these things by PowerPoint presentation. All these outputs will be taken into the PPT and there we will discuss these outputs. Take the variable tpstress. This was done in SPSS. Now this is the histogram. This histogram is indicating that the data is slightly positive skewed. If I am observing the graph, it is normal, but it is not like here. It is this. This is the part where we have a positive skewness. Right, the data is showing a positive skewness. This is an indication by the histogram. And after analyzing the histogram, the second output is the output of the normality test, Kolmogorov and Smirnov test. I am interested only in one figure. That figure is known as sig value, is also known as p-value in statistics. P-value is one of the important concepts in inferential statistics. So what is p-value in SPSS? P-value is sig. So whatever the value we have in the sig column is known as in statistics as p-value. So what sig values we have? We have sig values. This is the sig value of Kolmogorov test, and this is the sig value of Kolmogorov test, and this is the hypothesis testing accepting or rejection criteria. And H0 and H1 was already defined earlier. H0 is data is normal. Data is normal, data of perceived stress. Data is normal, and H1 data is not normal. H1 not normal. How we will take the decision? It's totally based on these sig values. The sig values are very important. You have to observe these two sig values. One sig value is 0, other sig value is 0.021. And if sig value is less than 0.05, then reject H0. So by Kolmogorov test, we will reject the null hypothesis of normally distributed data. So by Kolmogorov test, we can say that data is not normal. By Shapiro test, at 5% level, this is 5% level of significance. At 5% level of significance, we can say that Shapiro test will also reject the null hypothesis. So both tests are in perceived stress is not normal. So what we have to do, we can apply some transformation on this variable to make it normal, if it is possible. So what transformations are required and suggested? So earlier I have suggested square root transformation. How the square root transformation will be implemented in SPSS, I am just showing it. In the column transform, In the menu transform, we have first option as compute variable. Compute variable is one of the important option to generate the new variables. So can just click the compute variable transformation. The new variable will be what? Firstly, I am trying square root transformation, sqrt. sqrt of tpstress. This is the name of the new variable. sqrt because an indication that this is the square root of stress data. We have to apply a formula here on the right side, numeric expression. In the numeric expression, we have to pick a function. Which function? In arithmetic function, like Excel, you have the different functions, arithmetic function, date time function, and PDF, random numbers. These are the different functions. I am just picking the arithmetic functions. Arithmetic functions, in the bottom, you have different arithmetic functions. Absolute value, arcsine, arctangent, cosine, exponent, logarithm 10. This will be used for logarithmic transformation. This is the natural logarithm. I am interested in square root, sqrt function. It is here. Just double click here. Whenever you double click here, this function will comes into the numeric expression dialog box. You have to click now the variable for which you want to take the square root. We want to take the square root of the variable tpstress. So just click over the tpstress and click on the right arrow. tpstress will comes here. Now square root of stress. This is the formula. tpstress is equal to square root. As I told you previously, the formula is what? Formula is sqrt. This is the name of new variable, sqrt of tpstress. This is the name of the variable that I choose. tpstress is equal to what? Is equal to sqrt of stress under root of stress or tpstress. Actual name of the variable is not stress. Actual name of the variable is tpstress. Total perceived stress. Under root of stress. That nothing we are doing. We are just taking the square root of this stress. Just click OK. You can see one more column will be created, and that column is what? That column, I am just using this. This variable was not there before applying this command. sqrt of tpstress. This is the new variable, and this variable is created in the last of this data file. So you can see the new variable here. This is tpstress. Nothing we have the under root of the stress values. Whatever the stress value we have, this is just the square root of that. What I am going to consider again, another transformation I want to implement, and that transformation is the logarithmic transformation. So I'm just taking another variable is log of stress or tpstress. This is the new variable, and instead of sqrt, I want to use another function which is log10. This is the log function. Just double click the log function. You will have lg10. lg10 stands for the logarithm of base 10. Achha, now we have to pick the variable for which we have to calculate the logarithm. This is perceived stress. Click the right arrow. You will have the logarithm. Another column will be created, and the name of this column will be lg tpstress, log tpstress. So two new variables are created. One of them is tpstress, other of them is log of tpstress. Now you can see the data of the new column, 1 point something, 1 point something, and so on. These are the values of the logarithm. Now I want to check the normality of these two columns. If the square root of stress is normal, then I will use for inferential procedures further. Then if this is normal, then I will use this variable for inferential procedures. So we have to check the normality of these two as well. Now in analyze, descriptive, explore, pick two more columns, last two columns. These are the two columns, just select them and click the right arrow. Now I have three variables here. The other options are same. Plot section, we have a normality test that must be selected. Continue, okay. Now you can see that three variables are analyzed in the table. One of them is the actual variable, this is perceived stress. Second variable is square root of stress. Third variable is the logarithm of stress. The stress variable is considered with the three different versions. The mean of these variables and as well as the standard deviation are given. I'm not interested in these mean and variance. I'm interested in normal probability test, which are known as Kolmogorov and Smirnov test. These tests will be shown in the PPT. Here we can see that the histogram of total perceived stress and the histogram of square root of stress. So you can see that if I choose this option, then it is more closer to the normal if I exclude these elements as compared to the actual graph. As I told you, in the actual graph there is a positive skewness due to these bars. So if these bars are eliminated, then we can have. So you can see that the data is more closer to the normal distribution square root of stress as compared to. Now this is the probability plot. Probability plot is the QQ plot. I told you how this plot is constructed. Actual data is to be taken on the x-axis in the ascending order, and normal scores are on the y-axis. If the straight line we observe, if the data is on the straight line, we can say that the data is normally distributed. So we have some violation here. This violation is indicating that the violation of normality. As compared to this graph, we have very close to the line, these points are. So this is more normal as compared to this one. So TP square root of stress, we are suggesting that it is better to use as compared to the TP stress. Now these are the tests of normality for stress and as well as the square root of stress. And again, we can see that the p-value is 0 and the p-value becomes 0.02. So it's still the Kolmogorov is stating that the data is not at 5% level of significance, while the Shapiro test is suggesting that it is 0.98, it is greater than 0.05. We can say that according to the Shapiro test, the data is normally distributed. Data of square root of stress is normally distributed. So we are considering this is more closer as compared to it was 0 previously, now it is 0.02. So it is giving us a better option to use square root of stress as compared to the stress for parametric procedure in inferential statistics. Box plot of these two are indicating that box will be in more center as compared to this. It has few outliers we have here. These are the two outliers here. These are the few outliers here on the bottom side. So this is the box plot, and this is the table of TP stress, square root of stress, and logarithm of stress. So I have considered the three variables at a time. Now these three variables, three p-values are here. 0.0 logarithm. After taking logarithm, the p-value is 0. Before taking logarithm, the p-value is 0. That means logarithm will not change the value p statistics or p-value. But logarithm, instead of logarithm, if we are taking the square root, it is improving the p-value. If the p-value is large, then the null hypothesis is true. And in null hypothesis, we are assuming that the data is normally distributed. So we can see that by taking the logarithm, this p-value will be worst. So it means taking logarithm will not giving us any support. So we have to eliminate this variable logarithm of stress because it is not supporting us. While logarithm of, instead of logarithm, if we are taking the square root gives us a better p-value and it is much closer to the 0.05 and it's crossing that. So now conclusion of this test is I use total perceived stress as a actual variable. Then I take the logarithm of that and the square root of that. Square root for square root, it is better because the p-values are improving. If the p-value is greater than 0.05, 5% of level of significance, then we can say that the data is perfectly normal. According to the Shapiro test, it is 0.098. The Shapiro is indicating that it is perfectly normal, while Kolmogorov is as 0.02 means at 1% level of significance, Kolmogorov is saying that the data is normal, while Shapiro at 1% as well as at 5%, and it is closer to the 10%. That 1%, not 10%. At 1%, it is closer to the 1%. Now, gender-wise analysis of stress. If I select one variable in the factor, to consider the gender in this analysis, we have to move to the same option, descriptive measure, explore. One factor list is to be included here, and that factor is sex. Sex is a gender variable. Just you have to remaining three. I am just excluding one variable, which is log. I'm just excluding this because log will not supporting us the square root transformation and the actual variable, and we have to consider the gender-wise analysis. In plot segment, just click the normality option and OK. So we have now the data related with the gender-wise analysis. In the gender-wise analysis, we will focus on the output. tpstress, actual variable. These two graphs are the graph of the actual variable. But now this time, total perceived stress is not collectively graphed. It is graphed with the help of male and female data separately. This is the data for males. This is the data for females. We cannot take a clear-cut perception of normality in male and female by looking at these two graphs, so that we are moving to the p-values. Now the p-values of male in the actual variable is 0.015. It is 0.015. So it means at 5% level of significance, the data of male and female is not normal according to the Kolmogorov test. But according to the Shapiro test, both are normal. So if I am considering the tpstress directly without any transformation, Shapiro is saying that the data is normal because both p-values are more than 0.05. So it is much better to consider the tpstress variable without any transformation with the help of the factor variable, which is gender. The gender is considered and then data becomes normal without any transformation. The test again be performed on the square root transformation. You can see from 0.015, the p-value becomes 0.2, and 0.015, it becomes 0.49. The female's data will become approximately normal according to the whole group, while still the male's data is having the p-value which is 0.2. So we cannot clearly say that at 5% level of significance square root is normal, but at 1% level of significance we can say that the square root of males is the normally distributed data. And it is okay, 0.2 and it is 0.1, so both are okay, these are okay, but this was not okay. 1% both are okay, but at 5% both are not okay. This is at 1% this is okay, at 5% it is closer to the 5%, we can take a judgment. Box plots. Already have discussed the box plots. Box plot can be constructed and how box plot are interpreted. If this is the box, if the box width is high, then the high variance we have. If the box width is small, we have a lepto. Lepto and the box is wide, then we have a plateau. This is the interpretation of box plot. Again, box plot is indicating some outliers here, and that's all for this presentation. If transformation is failed, then we can use the non-parametric procedures, the Spearman rank correlation and Kruskal-Wallis test. These are the two names of the non-parametric test. These tests are suggested in inferential statistics. This is not the part of descriptive measures. This is the part of inferential procedures. So this can be used if the data will not become normal. That's all.